Now, let's get deeper into what exactly does a router do. A router is a very interesting device. It is at the heart of modern TCP/IP based internet. We are interested in determining what happens when an IP datagram arrives at a router. A whole process called the input port processing starts. In this module, we shall understand first how router processes information, what happens at the router input port, and is there any exceptional condition that could emerge which a router has to take care of. A router is like an engine that performs two primary functionalities. First, it performs routing in itself. It uses shortest path finding algorithms and protocols. And then, for an incoming packet, depending on the information that it has built, it is going to forward the packet. Illustratively speaking, we have the figure here. This has been taken through courtesy of Quiroz and Ross. What we see here is we have the routing as a process on the top. Then we have a switching fabric that performs forwarding for the packets which are coming on the input port and forwards them to the output port. It is important to remind ourselves here that the input port and output port essentially imply symmetric ports. That is, an input port could be an output port for another input port and vice versa. The router input interface could be seen as comprising these modular functionalities. For example, a router is also a layer 2 device, so it performs switching. A router is also a layer 1 device, so it performs line termination and data link layer processing, protocol decapsulation. And of course, for the incoming packets, they have to be queued somewhere, so it also performs queuing as an additional functionality. The distributed switching is a very interesting concept. It arises from a nice amalgamation and combination of routing behavior and forwarding behavior. That is, when an IP datagram arrives at this input port, it has to be switched up to another output port. Which output port it has to be switched to? This decision is the distributed decision, which has already been pre-computed using the routing process. Although a router is performing all these functionalities, including the IP header processing as well, but it is always desired that a router does this at line speed. However, achieving the line speed is not possible. Therefore, all the vendors of various networking devices are trying their best to come up with very fast switching fabrics which are offering closer to line speed performances. Another important process that takes place at the input is the queuing itself. Why does this happen? This happens when the switching fabric is slow. For instance, it is based on bus architecture. In that case, the input queue would generate enough data, would have enough data that the switching fabric cannot forward. Consequently, the input queues would start getting filled up. Illustratively, we can imagine that we have this 3 input queue system. The arrival of the packets is fast. Consequently, a slow switching fabric is not able to handle them at a high rate. What will happen is the input queues would start getting filled up with more incoming datagrams, and a time could come when the individual input ports could overflow.